Welcome back, everybody. So, for today's video, we're going to be talking about applications of double integrals. The applications we're going to be talking about here are primarily physics, engineering related. There are applications that deal with other fields. So, quite often when you're dealing with a joint probability distribution for statistics, you'll have to deal with integrating over multiple different variables. So that's a very common thing if you're doing any sort of statistical work. Other fields still use these as well. Maybe not as common as other ones do, but they still have applications within most fields. All right, so let's go ahead and get started. First thing, we're going to be talking about density and mass. One of the advantages of a double integral is you can find the mass of an object with a different set of density depending on its position. So a lot of things might have similar density and be the same all the way across, but sometimes it is not. So it will change based off what material's in it in a particular spot and so on and so forth. And this can cause some issues. So depending on how you have it set up, if you have your density function and you know the area you're integrating it over, you can find the mass just by doing the double integral over the area. And that's a fairly useful thing to know. Next part, you have moments and centers of mass. So just knowing what the mass is great, but knowing what the center of it is slightly more important. Especially for anybody going into engineering, especially aerospace or anything like that, you need to know where the center of mass is to make sure you have the forces going in the correct direction. So thankfully the formula is very similar. So for the moment around the x-axis, you also include a y inside. You have the same density, everything else is still the same. You just put a y for the one with x. It's slightly odd, but that's the way it ends up working. Similarly, you do the same thing for the moment around y. Now, these are useful for finding your moments. You can also find your center of mass by just taking these moments and dividing them by your mass. And that just tells you where the center of mass of your object is. So hopefully that helps out a little bit. And the third aspect about these that we're going to be dealing with is moment of inertia. So for this one, we're not changing too much. Instead of dealing with y times your density, you'll have y squared and x squared for the y version. So it's just a little bit of a switch there. So nothing too difficult. So these are on the axis, but you also have a situation where you can find the moment of inertia around the origin. And all you have to do for that is add the two of them together. Hopefully that's a slightly informative video, and I will see you in class.